And yes, it's Monday again.
We used that today.
Yes, we did.
Damn. You know, everybody, they'd be proud of us, but I don't think we should talk about it because something will happen.
Ampersand.
Yeah,
Man.
we did. You know, I want to ask about that. My bet was that most people wouldn't know what it is.
All right, we'll get into that.
I mean, we knew.
That'll be a little bit of before we get the guest.
Yeah. We got a guest tonight?
Yep.
Oh, yeah.
Anybody good?
We'll go through our spiel, power and speed, and then have Ted.
Is that who we are? Power and yeah.
Stumble over all
That's
this
right.
shit.
We are. Power and speed. On Monday again. 908-751-0211. You guys can call in tonight, but we're probably not going to answer you. So.
Yeah, right.
No, actually, I would encourage him to call in.
Yeah,
I'll let Tad finish. Go ahead, Tad.
Okay,
Try to
make-
assemble this thought. Go
Sure,
ahead.
just make
Go.
sure to share us first, and then like us on iTunes, Facebook, yada, 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 all that.
I don't think yada,
What?
yada, yada really drives the point home, bud.
You yell at them. Don't yell at them. Don't be mean. Don't be.
Let him run with yada yada.
Okay.
Yeah, yada, yada, yada.
All right.
What we'd like people to do is go check out the fan page because that's where a lot of people talk.
That too.
Fan page is good. If you see something or hear something you like, share it. You know, I guess that social media stuff has to pay off sooner or later.
You would hope.
I would hope.
Tell
Tad
others.
worked so hard at it.
Oh, yeah. Didn't we hire him to kind of do that?
Specifically?
Yeah, wasn't that one of the strengths?
Yeah.
Yep. Hey, and I have been freaking seeding other freaking forums with our.
Yes, you have been.
So-
You have been doing a little bit, so we'll give you a little bit of a pass there. All right, couple quick things. Scott North, good guy from Utah. He was like our first Utite,
Utite.
whatever they are.
Yushin?
Oh,
He was kind of our first guy.
He's a Ute.
Now, believe it or not, in the great state of Utah, it looks like there's somewhere in the neighborhood of 2,500 to 5,000.
really?
So,
That's a big window.
yeah, it's kind of, again, this is all subjective and it's hard to tell.
But Scott North is number one.
Yes, he is always our favorite
Ute.
Interesting country demographics. Canada. Come on, man. We got PJ. We got Matt Blasco. We
Oh, I
got
thought you were going to play the soundbite.
no, yeah, we
Take off,
could.
hoser,
Take
hey.
off, you hoser. We've got Matt Blasco, PJ, Richard Guido. There's a whole bunch of people from Canada that listen. But you guys
Listen.
are actually in third place.
Listen, you kidding? They drive how far just to come down here to do drag week and
Yes.
stuff. So
Is Bankshift Billy Canadian?
No, he's
Oh, that's right. He's from
Colorado.
Yeah.
Yep.
So he's almost Canadian.
Yep. No.
I know. I don't know. Whatever.
Canada is actually third in the listener totals. Second, to the U.S. Obviously, there's just probably more car guys here. Australia.
Go Australia.
So Aaron and company that actually set up the fan page.
Was Aaron our first guy?
He was? Yeah, I think he probably
Yeah.
was, or he's the first guy at least made contact with us. So yeah, that was
but there are some blank spots in Australia. So
yeah, the Northern Territory, which I don't know what that composes or what
it composes something that you insulted them. They refused to listen to.
I
so.
must have said something, but it can't be any worse than Tasmania. We apparently have people in Tasmania, and people were
Really?
they were very hard on the Tasmites or whoever they are. Tasmanians.
I don't know. I got nothing.
Yeah, they were quite some disparaging comments, but we love you guys, and we're glad that everybody listens. Worst U.S. state? Get a guess?
Yeah, I do.
Hawaii?
No.
Maine.
Yes.
Really?
Maine.
It's got a lot of geography and not a lot of people. And
Any drag strips?
I guess.
I don't know. Are there?
Yeah, I think there is. I know there's circle track stuff up there. But, I don't know. It's really big, and there's not a lot of people.
50.
50 people.
Approximately 50 people listen. Approximately 50.
Let's block the rest of Maine. If they can't break 100, we should just block them. That's my vote.
I just thought that was all kind of interesting.
It is
Like
interesting.
who's listening where.
I don't believe I guessed the right state.
Well, for the longest time, it was of all things Connecticut.
Really?
Yeah, well, let's not go down that
Yeah,
road.
I know,
That
I know.
starts a whole nother
Yeah.
conversation.
Yep.
But yeah, Connecticut was bad. Now it seems to be Maine. So no, I don't know. I'm sure I'm speaking for both you guys. Amazing. We really didn't expect this. So
I did.
Wait. We or FUD?
well, FUD expected a total of 250 listeners. So
Fudd's dumb as a mud fence, by the way.
Mud fence.
that's a new one.
Yeah.
So, yeah, but I mean, I was hoping it would be decent, but this is
It's
much
pretty
more
good.
than we thought, and we've got all kinds of interesting opportunities that are cropping up.
Can we take a little credit?
For what?
I don't know. We thought of something, and we're doing something that nobody else kind of does the way we do.
I I guess so, but I
We're-
mean,
we're a
really,
little
we're
special.
What a
yeah, but we're
podcast?
just idiots.
We used that today too.
Yes.
Twice. Yep.
Yes. So you want to talk about that because
Yeah,
at
we
least we
could.
got some progress.
Yeah, we could. So we hired a woman on a listener's advice to do our logo. We had a conference call with her today. She's the real deal. We paid her already. Well, I paid her. We paid her. I just made sure she was paid. And had a good conference call. We laid out some ideas. We emailed and texted back and forth for, I don't know, 30, 40 minutes?
Yeah.
And the shirt stuff, we should have some preliminaries this week. And you don't even know this, Mike. I found a shirt company that I want to use.
Okay.
What state?
T-shirts are made in the U.S. They're actually made here, which makes me happy. So it'd be like us and Gene Fulton would be the only two car companies that I know of that buy apparel that is made in the U.S.
Okay.
Because I like that.
Okay. I'm all right with that.
Ditto.
I'm good with that.
And I got one, and they're nice shirts.
Okay. So now we just need something to put on them.
We're working on that. Obviously, that's what the call was about. And we opened a phone call with this girl today. I did because Mike hadn't talked to her before, and I said, Mike, just so you know, I've already explained to her that we're both idiots, and she started laughing.
Well, it's really hard. I mean, you know, everybody says, well, you do a podcast, you're not creative. No, this takes like zero creativity.
No, yeah.
It just takes a little bit of conversation and personality. That's
Right.
all this takes. It has nothing to do with creativity.
Yep.
Personality?
Yeah. We're working on you,
Go
Ted.
back
You'll
to
get
sleep,
better.
Ted.
The things like artwork and T-shirts and marketing, like she was saying stuff, well, what do you use on your social media for hashtags?
We're like, what?
And I'm like,
What other?
I've been the one
How about
talking about that. So
what other social media do you use, or what are you going to use this for? Like,
Yeah.
Like, I don't know. What should we be using it for? We're making shirts.
yeah, shirts. And she's like, well, the podcast logo is square. And I mean, look, I get it. But I think she's looking at it more from the other side.
Well, that's why I explained to her how we want to lay it out, possibly. And I think by the time we were done, she understood.
Mhm.
And we gave her a bunch of good logo ideas.
Yeah, and she was looking for, are there any things that you guys always say? And I was like, well, another Monday or here's Monday or whatever.
Yeah.
Thanks for calling was one of them, but that was
Yeah.
kind of old.
Yeah. It's old.
You know, I don't know. We'll see what she comes up with.
I think it's going to be okay. I really do. But I'm an optimist. I'm the one who said we were going to potentially win Drag Week.
Yeah. Yeah.
They're asking for an update, by the way.
Mhm.
Yeah.
I'm going to allow you to handle that at the end of the show.
Okay.
I'll let you take care of that one.
I'm just going to put it off till next week.
Okay.
Drag Week. What the hell's that?
Yeah. What's that? Let's talk about our guest that's coming, because this is probably, you know, at least to me, one of the most exciting guests we could have. And
Me too. And we've had a lot of good ones.
we've had a lot of good ones, a lot of really good ones.
He's up there in the top, 3, 4, 5 for
Mhm.
sure. And he's one of the smarter guys for sure.
Yeah, I kind of don't think we're going to talk to anybody that is, I will say, I don't know how to say this because I don't want to offend anybody else to spit on, but the level of understanding of kind of things, he's got a pretty amazing set of credentials, but we'll go over all that when he actually comes on. But it's Billy Godbold from Comp Cams. We promoted it all week, or pretty much all week, so
Yep.
everybody knew it was going to happen.
Yep.
We got questions from Facebook. So you guys put in questions. Of course, we have some of our own. And I think, like, looking through the questions here, I think there's probably a fair amount of them that are going to be answered, like, in discussion. Like, Tom and I both familiarized ourselves with the questions, and there's going to be things that, like, when we talk about, like, maybe cam cores and stability, like somebody had asked about cam twist and how much of that really happens. A guy that I think it was William Fowler wrote in about camshaft, size, like not the lift and duration.
Yeah, the physical size of the core.
Size.
Yep.
And Billy was nice enough to post like a whole chart how they do it. So because there's a lot that goes on there.
Sure.
I mean, you can't just take the cam and make it bigger because then everything gets bigger. So they do translation.
Yep.
So there's a lot of good stuff there. So some of this stuff, we might not ask your question directly, but we're aware of what you're looking for, and hopefully it'll just get answered in the course of the conversation. That's kind of what we're hoping for.
Yep. There are a lot of questions.
Yeah. Yeah.
And I guess Tad is going to be looking at the chat room, or are we not looking at the chat room at all?
Well, Tad, you can look at the chat room. And I mean, I don't I don't mean to tax your mental abilities here, but if there's something that kind of fits right in topic, or you saw something, you could be like, oh, so-and-so asked about that if you could.
Actually, the one question I saw about is posted on our page, or the not our page, but our fan page.
Then I have it in front of you.
Was asking about the larger ratio rocker arms. You know, when do you want to go for a larger ratio as compared or not?
Yeah, that was Richard that asked that, and I can tell you that on the 2-barrel stuff, and I know people had said, oh, don't talk about flat tapped stuff. You know, I think specifically Mogul said that. The flat tapped stuff puts another set of constraints on things that you have to work around, like the nose radius of the camshaft. And look, when you're dealing with an 842 lifter, you can only lift so aggressively.
Yeah,
and
before you hit it.
Well, yeah, because if you picture it, when the thing's going to turn around, it'll dig in the side. So now it's hard to get lift component if you're going to run something that's short in duration, like say in the 240s. How are you going to get a lot of lift? Because there's no real estate there. You can't. That's part of why
the ramp be too aggressive and it would drag the lifter.
And then the next thing that comes in is the nose radius. If you put more and more lift in it, you're getting to the point that when you got to the end, like you're accelerating the same speed all the way up the ramp, you'll have an razor sharp point.
Mm-hmm.
Well, then of course, as soon as you start it up, it'll knock that right off.
Mm-hmm.
Yeah.
So lifter ratio and all that stuff kind of plays. Rocker ratio kind of plays into all that stuff. So I am a fan of it in some areas, and some of the drag race stuff we used a lot of rocker ratio, but these things can change. You know, as cams got better, as cam structures got better, as lobe designs got better. And you've also got the multiplication of the force of the valve spring on the push rod.
Yep.
Because it works the opposite way.
Yep.
And, acceleration rate. What is that? Hertzian stress? I don't know. That's Billy. Listen,
Billy will know that.
I want everybody to make sure that they pay attention to some of these words. And the good news is, since this is a podcast, you can download it later. Because the first time I talked to this cat, I actually had to consult Google to look up some of the things he said, because I didn't want to.
Many times.
Yeah, many times. I didn't want to look like an idiot being like, all right, hold on, stop with that big word.
Yeah.
Because he's an extremely sharp guy. But I think everybody's going to get a lot of this. I think.
I'd like to think we don't bring many dullards on.
Say what?
We don't bring in many dullards onto our show.
Oh, on the show?
Yeah.
I mean,
is that a real word?
Probably.
You looked it up just now?
The dingus did.
Nice.
Somebody actually asked, like, kind of what the purpose of the show was overall, the show. Like, why did you do it? And
obviously to make money.
Well, when the guy asked me on the telephone, he
that
goes,
was a failure.
Yeah. Well, I mean, we haven't done anything yet.
I know.
But like I said, there's stuff there.
Yep.
What is the purpose of the show? When the guy asked me, I said, I don't know, to combat internet dumbassery.
Yeah.
And I think that so far we've done a pretty good job.
We have. And it's funny. We all joined that, what is it? Engine Building 101.
Yeah.
And not knocking it at all, but it's hard not to knock.
Yeah, that's Anthony. Anthony did that.
There's still more idiots keep on piling on there.
Yeah.
So.
It's a good site, but man, you just have no control over the idiots.
The internet's, it's wonderful and it's horrible.
Yep.
Because you can find anything to support any theory in any direction, as crazy as it may be.
Yeah.
Mm-hmm.
So we'd like to hope that the people that we get on, and some of the stuff is open to interpretation. There's going to be things like the questions that, like, well, what's the right camshaft? There probably is no right camshaft.
That's theoretical.
Right.
Yep.
And, like if you have people that, are trying to draw a distinction between opinion and fact, that's where it gets tough. But some of the stuff is just factually wrong. So hopefully, like the guests like Billy and everybody else will raise everybody's level of what's real and what's not.
Sure.
That's what I'm hoping for anyway.
I think we've been pretty good at that. We've been good at actually getting real information that kind of can't be argued. And I like to think it's because, we know a little bit. We know enough to know what's kind of wrong and what's right directionally. And the guests that we've had have been, on point. They just have.
Mm-hmm.
So,
and, there's been a lot of times that I wanted to chime in and say more than I've said about a given subject, but I know part of this is a pitfall. It's a trap. Like, as you're going to say something, and there are reasons that maybe something you would do that somebody else wouldn't do. And camshafts are look, I'm with you and probably with Paul. Everything in this world has a math explanation.
Yep.
Everything can be explained by math.
Yep.
But some of the math, either we can't understand it or it's very difficult to measure.
Sure.
Like if math was absolutely 100% understood, loggable, and everything from a data point, you could use an engine analysis program. Now, look, maybe they've gotten better, but we worked with a guy. I can't remember the name of the company, and I really wouldn't want to bash him anyway because he's a super nice guy. But he came up with this whole enormous program to generate horsepower and torque characteristics and everything. We couldn't get it close on a superstock motor, not anywhere near. It was so far off, it was stupid. And the guy's like, well, there are some factors here. And then, you changed a couple little things that were like sort of the fudge factor things.
Why can't I think of his name? Because I know who it is. He passed away like a year and a half ago.
Did he?
Yeah, he wrote a big book and a real smart guy. But I thought he was more into analysis and predicting what you need for a valve spring or a rocket ratio or a push rod or that kind of stuff.
Well, this was an overall horsepower prediction. Like it would tell you torque and horsepower.
Yeah, it would get to that. But I mean, you had to base it on flow characteristics of the cylinder heads, and
we did all that. We spent, and like they wanted very precise measurements, like
why can't I think of his
under
name?
the valve seat, this far up the port. They wanted kind of short term in a short turn in 3 places.
Yep.
They wanted a lot of
all
stuff.
the percentages. Yep.
And we tried, and just for whatever reason on those particular engines, it would never come close. It was off on that. It was off on 2 barrels too.
Yeah, I'm trying to look away and I know who it is because I have 2 customers that both bought that program, and it wasn't cheap.
Mm-hmm.
Like I want to say it was like $20,000.
Oh, I don't know if we ever got to the point that we discussed actual pricing.
Yeah,
I think it was more of an exercise in giving it a try.
I'll think of it. Yeah, I don't know.
Okay.
Are you talking about Sheldon kind of math? That's with all these little squiggles and stuff like that. And
well, like I said, some of the stuff is probably theory, and anything like one of the things that I want to ask Billy about is like from the Spintron perspective. Data's data. When it gives you data, you have to process that data to arrive at a proper conclusion. One of my questions to him, has there ever been a time that a Spintron session that like you saw something you needed to correct and then you went back to correct it and the motor got worse?
Well, you went back and corrected it.
Yeah, back and like corrected, like let's say that, a stiffer push rod or double taper push rod, something, made the valve tray more stable. Did it ever get worse? And then you had to go back and say, well, why did the data tell us that?
Why did it get worse?
Well, the simple answer to that in my world would be, because I've seen it is, you have a valve out of control and you don't know how out of control it is. So you throw spring pressure at it and you control the valve spring and the valve and you're down 25 horsepower.
That's Brent comes into like the discussion that we had talked about with Cup and with everything else.
Yeah.
This controlled toss.
Right.
I could understand, like if you were trying to make a cam, I guess say, or a Spintron chart follow exactly the profile of the camshaft and the toss was beneficial, well then yes, you'd lose power.
Right.
But that's probably not considered like a chaotic valve event.
No, that's why they call it control toss. Yeah.
Yeah. Well, we finally got him.
Yes.
Here he is. Billy Godbold, how are you, sir?
Doing great. How are you guys?
Really looking forward to this. This has been a very exciting week for all of us.
Yeah, it really has.
There's so much here, and you're so qualified to answer this. I answer all these questions. I think it's just the best thing we could ever hope for.
Well, thank you very much. I sincerely appreciate it.
You're more than welcome.
Yeah, it's going to be fun. We have a lot of people with a lot of interest, and hopefully we all can learn. I know I'm going to learn some stuff.
Well, let's start here. And Billy, I hate to do this, and I hate to put people on the spot, but
go ahead.
Could you tell us a little about how you got to where you are today? How did you land at Comp Cams?
Well, I was going to be in nuclear physics. I had a fellowship at Florida State University and was working my PhD. And about that time, there were some political changes, and they stopped a major project called the Superconducting Super Collider out in Texas. And when that happened, about 1,000 PhDs lost their major source of fundage. And there was about 100 good jobs that came up in my field each year. And it really didn't take a nuclear physicist to think that when you have 1,000 jobs empty, and 100 get filled each year, that being the low man on the totem pole was not a good place to be.
Oh, yeah.
So I was going to go into medical physics. I came back to Memphis, and just bide my time. I went to work, read an ad in the paper, and went to work in a tech line here at a little place called Competition Cams. We were about 40 people, and I've worked for Scooter ever since.
Wow.
Yeah. In a couple of, one of these days I'm going to grow up and get a real job.
No, don't do it, man. Keep fighting
There
it.
we go.
Keep fighting it.
Right. 19, they hired me in 94 and started in 1995. And
Well, I think the time that I talked to you, and I only worked with you on one particular engine product and one particular combination. And I remember talking to Gordon, and Gordon said, "You got to talk to this kid," because Gordon, everybody was a kid because he was.
Yeah. Oh, absolutely. Trust me.
And he's like, this kid is the sharpest kid we've ever had here. He's like the superstar. And then that's, was a whole flat tappet thing. I'm sure there's probably not a chance in hell you remember it, but it was really an exercise in learning specifically about the nuances of flat tappets. It was
Right.
It was fun. I had a lot of good times with that. So we're hoping that what'll happen here is a bunch of questions that people have, and maybe some of the mystery will be cleared up. But now you were pretty quick to state that you're the theoretical side, and like,
well, yeah. Well, see, there's something that people think when they say cam design. People talk about great cam designers. They'll mention somebody like, Gordon or John over at Little, LJMS, or guys like that. And those guys actually select the cam profiles. They more pick timing points, duration, lift, things like that. But they're not really designing the dynamic side of a camshaft. Like Gordon is way better at picking a camshaft from a clean sheet of paper than I am. But all of the lobes that he'll use, I design the lobes. But then if you get into something off the wall, say, if it's somebody converting a weed eater from 2-stroke to 4-stroke, or an engine that does shipbuilding, or even I've done a compressor behind the pilot for an F-16, a little iron lung system with 3 lobes on it. So, if it's really crazy, I can do a really good job of that. If it's something more standard like a catalog cam, where those guys would just pick one cam, I'd pick a matrix of cams, and we'd test, 3 cams, move them different places, grind 3 more, do different places, and I'd be on the 8 or 9 camshafts before I pick the right cam we did for a catalog grind or something. So while I do design some of the cams we have in the catalog as far as picking durations, there's guys who are far better at that. If you needed to pick a camshaft for an application, I'd be glad to give anyone a name for a certain type application. We got guys that do dirt track, and we've got guys who do pro stock, and we've got guys who do, boosted double overhead cam forwards, and there's different guys inside the comp umbrella that are good at all that sort of stuff.
yeah, and they have exposure to that particular, set of combinations, because some of this is practical experience, what you've learned over time.
Exactly, and I'm just extraordinarily fortunate because, from the time I came into the business, I was allowed to talk with a wonderful select group of customers, and a bunch of these have become friends. Guys that we've lost, like John Lingenfelter, who's probably my favorite of all time. Grumpy, just a ton of great guys like that, but also a bunch of guys that are still older but top of their game. Kenny Duttweiler, John Kazi. When I first started here, Doug Yates was just like a kid in the dyno cell doing development motors. So I got to work with guys like that. So, I get to work with some of the best customers on the planet, and that gives me a huge advantage, but also gets me a chance to play with some cool stuff.
Yeah, for sure.
But my job basically entails I design the lobes at Comp, and I help our salesmen on the theory and testing and development of stuff. As far as, if you need a camshaft for a 1987 Electra 225 with a 2-barrel that races on, this dirt track in Idaho, I'm probably not the guy to get the first camshaft for it.
Mm-hmm.
But you'd be the guy to put the lobes on the right camshaft.
Exactly. I would probably be the guy who designed the lobes, and the guy that talked about flow with the salesman, flow percentage intake to exhaust, and how do we change duration based on that? What rocker ratios will we want to use? What can we do with the, Buick has a smaller cam journal, so how does that limit the cam profiles we can use? All the theoretical stuff like that.
Okay.
That's good, because there's a lot of questions based on a lot of that stuff.
Well,
right, and that I was really glad that I didn't see a lot of questions that I saw on Facebook. They weren't about picking a cam. They were like, how do I think about this? And that's more my strength is, how do we approach a problem? How do we think about a problem? How do we make good data-driven decisions, and less about exactly what the final answer is?
Right. So there's got to be certain, like, I want to say, basic principles that maybe govern camshafts.
Oh, absolutely.
Like duration must have a basic principle or theory behind it, I guess, with exceptions. Same thing with lobe separation, installed intake center line. All those things probably have general tendencies that I think would be the same. And, that would probably carry through just about anything, I would imagine. And
absolutely.
I think maybe we should start there for some of these guys.
Yeah, a lot of the things is what we standardize around. Where we kind of start with is the valve diameters, and I know you'd like that. With your background,
sure.
That start with the diameter of the valve, but you know this as well as anyone. Tom, when you sit there and you have a valve that's 2-inch diameter, if you start looking about old school, would have been that the lift needed to be about 20% of that. So that's why you saw the old 400 lift camshafts.
Yep.
And then as valve seats got, the valve seat work got better, all the back cuts, all the ports around there, you saw the industry move from 20% lift to diameter toward 25%.
Yep.
Now what we see is that most modern ports want to see about 30% lift to diameter. And that's just for a street, just any basic engine with a good, just a decent valve job, not even a great one. Anything like that is going to want to be about 30% lift to diameter. But then you get on the race side, and it's going to move up significantly from there. 35% would be like a 24-hour type race. When you get to the more, basically you look at the NASCAR side, they're probably about 38 to 42%, so around 40%. A person in super stock is probably close to 45%, and some of the pro stock even starts flirting up like 48%. When you get past about 40%, those are for steeper valve seats, of course. You don't see over 40% lift to diameter ratio on a 45-degree seat, but you will see it on a 50-degree seat. And when you get up around 53, 55-degree seats, you'll see people pushing toward that 50% lift to diameter ratio. I was at a show in Cologne, Germany, an automotive show, motorsports show in Cologne, Germany, and had the pleasure of talking to a F1 guy who was involved in valve train. And so I asked him, I said, what lift do you guys run? This was when they were running, before they put the RPM limits, and they were running over 18,000 RPM. And I'm like, well, what lift do you run? And he's like, in his strongest German accent, well, that's a trade secret, and he'd have to kill me if he told me. So I asked him, I said, well, I tell you what, what's the relative about, what is your valve diameter? And he told me, I said, well, okay, and I forgot what it was, say it was 40 millimeter, and I said, well, okay, so your valve lifts about 20 millimeter. And you could think the guy could have choked me, I said, it may be like 17.5 millimeter if you're 45-degree seat, but if you're a 50-degree seat or more, it's probably close to 20 millimeter, and close to 50%. And he just, he acted like I had stolen the code, where, and that works whether you're dealing with. Again, this is back one of those things you can get relative. That works on weed eaters. It works on ship motors. It can be a valve the size of the tip of your pinky, or the valve that's bigger than your chair, and it would still need to be in that range. Clearly, if you have the really shallow seats, the 30-degree seats, those are fine with much less. So a ship motor probably would be a shallower seat, so it probably would be under 20%, but still, it's relative. And then when you start looking at durations, duration at 50 doesn't mean a whole lot when you have a valve the size of your pinky. So you probably need to scale a little bit on where you're looking at the durations. Or you can just think, okay, well, since that's at a lower lifted diameter, I need to expect that to be bigger on a bigger valve.
Got it.
And how about like
Now
some
that I've
principles on lobe
confused everybody in
separation?
the world. Lobe separation, a lot of people want to get very, very specific on lobe separation angles and center lines. And we move center lines, but what we're really trying to work with is valve events. One time we were working on a Chrysler application, one of the Neon applications. It had a follower, a swinging roller follower that limited the symmetry of the valve motion, meaning that like on the intake side it needed to be slow opening and fast closing, and the exhaust side had to be slow opening and the opposite of that.
Mm-hmm.
And so I was really worried because I wanted it to act like it was like a 115 lobe separation, but to get that valve timing I had to put it on a 105 lobe separation to get the valve events to act like they would on 115. And to do that, so I ground the cam on a 105, and I was a little worried, well, would it act weird on that tight lobe separation? In fact, engines don't really respond to the center lines as much as they respond to the valve event. So it acted just like it was on a 115, even though because of the weird asymmetric lobes that peak lift, where peak lift actually occurs, the motor's not as sensitive to that, and all your center lines are given as peak lift center lines, not as the lower lifts. So, looking down at the 20 and 50 number center lines, where that would be, it's given as peak lift center lines. So you start putting asymmetric lobes on there, and then all of a sudden your center lines don't really mean very much.
Mm-hmm. I'm going to have to listen to the show like 7
Again,
times.
I confused another. I'm so sorry. I'm going to try to keep things more simple. So
No. There's nothing simple about it except the guys behind the microphones, really.
Yeah.
I'm really bad about doing that. So usually people ask a question and I give an answer and they have 10 more questions and they start it.
And that's the beauty of this process. I mean, that's how you learn. I'd encourage, and I said at the beginning of the show, that if there's things that are said that you don't quite understand, maybe go to some verifiable sources and try to at least look up the terms. But events are really the driving factor behind how the cam is center lined, installed, and ground. So yes,
even though we spec cams in terms of durations and center lines, we're really trying to optimize the events. So as long as you remember that, you can actually talk about durations and lobe separations. We often do that because that's how we grind camshafts. So somebody goes, okay, I'm running a one of those new factory stock classes, and I've got a 2.3 liter blower, and I'll actually give them, whether it's a Ford or a Chrysler or Chevy, I'll give them durations and center lines to start with. But what I'm really looking at when I start, saying that doing cam one, let's put one out in the fairway. It's kind of like playing golf and grabbing your 3-iron if you could play golf. And let's put one on the fairway. We'll get, my son and I shoot a lot of competitive rifle shooting long distance. And a lot of times we're putting a hole on paper. And then after we get that hole in the paper, then you adjust your dope. And then you put another hole in paper, and then you work from there. So a lot of times when I'm doing camshafts, I'm doing it more like I would as a competitive shooter, not as you would think. I'm trying to see how the engine responds to each valve event. Mm-hmm. And when I start doing them, I told you about trying to do 6 or 7 cams at the first. What I'll do is I'll grind 2 camshafts that are the same, except maybe the intake closing's moved or maybe the exhaust opening is moved. So I can see how the engine responds to that one valve timing a point instead of just all the durations. Because if you change the duration or the lobe separation, oftentimes, like if you change the duration by 4 degrees on intake and exhaust and the lobe separation by 1 degree, you've changed all 4 points. Mm-hmm. So you really need to see how it works independently, how each point, how a motor responds to exhaust opening, intake closing, intake opening, exhaust closing.
And with for most of what we deal with, we have 1 camshaft. We don't have 2. So
I know
that makes it tough.
It makes it tough, and it makes it where that's why we often go to the dyno. Somebody was asking me on one of the shows, can I spec a cam? And I said, well, I'm not that good at it. And he goes, well, I heard you did the cams in, for Kenny Detweiler for a Speed Demon. I heard you did something for one of the pro stock guys that won a championship. I'm like, well, yes, I did. And they're like, well, what do you mean you aren't good at picking a cam? I'm like, well, they let me pick like 6 or 8, at a time, and it gets real easy after you get to throw that many at it,
One of them finally works, right?
Yeah, exactly. Okay, well, I found, I lost, you take a guy like Gordon or I, I can get where Gordon will, I'll be on cam 4 or 5, I'll be where Gordon was on cam 1,
Mm-hmm.
But hopefully I learned a lot on those first 4 or 5, so I'll know what 6, 7, and 8 will do.
That's quite an endorsement for Gordon.
Yeah.
Yeah, he's awfully good.
That's a lot of experience there.
A tremendous amount of experience, and he is. Another blessing is having guys like that. Having Gordon and Scooter, Dean Harvey, James Fry, a bunch of the guys who are just stalwarts of our industry take me under their wing from the time I was a little kid till, now I'm in my mid-40s, and those guys will still do anything in the world for me.
Yeah,
that's great. I have a question completely off the subject.
Sure.
You said competitive shooter. Mike and I both shoot. I don't want to spend a lot of time, but what kind of distances?
No, 600 and 1,000 yards.
Okay, yeah.
My son and I were in shooting F class. His gun's an FTR because he wanted to shoot a military type deal. He doesn't like the tripods and everything, like shooting off a bipod or offhand. Yep. And he even thinks the back bag is cheating. So a lot of times he'll let his float. But he set a national record for juniors at 300 yards. That was like broken a couple weeks later. But I guess he held one for a little bit on his first meet. Me thinking that I was a better shot than my son, I went and shot F open. So I was shooting a 283 Winchester. He was shooting a 308. And, my ranking was a little bit better than his, but it was because I was shooting a gun that, when I miss a wing call, if his would miss by, 4 inches, mine would miss by 2 inches. So, it was a lot better shooting the 7mm. But,
nice.
But what's funny is I thought I didn't want to ever beat him in a competition, so I shot a different class. And it didn't take me very long to realize I would have never beat him in a competition.
Well, at least you didn't have to face that one head on then.
Right, exactly. At least I didn't get whooped by my kid over and over again is what it meant.
Well, how old's your kid?
I have 5 kids, but the son that I shoot with, he is 20 years old. He's going to be a junior at University of Tennessee, Knoxville.
Nice.
Very nice.
Yeah. Yep.
Well, I find that I get proud when my kid beats me at something.
Yeah, well, he's really good at he was really good at shooting. But that was one of the things. He's of the 5 kids, I've got awesome kids, but like my stepdaughter does ballet, which I can't relate to that at all. I love it and I love watching her, but the relating to it is never going to happen. And one of my daughters, she does a lot of photography and she does journalism and stuff like that, and I can't help with that. But my son, who's an engineer and a competitive shooter, I can get that.
Yeah, you're right in there.
Yeah, right, exactly. We can talk differently.
That's nice. Well, listen, Mike's been talking about a question that he's been he's had in his head, the Spintron question. I think it's a great question.
Well, it is, because it comes back to something that I think plagues anybody that does any development or any research, and it's data. If you misinterpret the data, or you get bad data or data you can't trust, then you could get sent off in the wrong direction. And so my question would be, has there ever been a situation where a Spintron session yielded a particular result that you thought would have been detrimental, and then went through some valve train changes to correct it, and you actually got worse in power output?
Oh, the Spintron is absolutely, it proves to me just how dumb I am every day. It is, people call dynos lie detectors or dream killers, and a Spintron is just one more step in data that pulls you in. It used to be that people would think that, I'm going to put a slower closing ramp on a camshaft, and that's going to calm it down. And like the first thing I learned on a Spintron is, it's kind of like, if you slap somebody really hard, asking them to do something for you later is probably not a good idea. And valve springs aren't any different than that. Like if you take the one of the old cam designers, I used to call him the John Daly of cam designers. He'd grip it, rip it, and then try to put a tail on it and make it close.
Right.
But when we tried to do that sort of stuff, some of the camshafts I used to do, major intensities is the time it takes to go from 20 to 50 and then back from 50 to 20.
Mm-hmm.
And some of the splits I used to do on 30-degree major intensity cams were 14 degrees on the opening and 16 degrees on the closing. So giving it 2 more degrees to close than you gave it to open. And I tried to run some of those on a Spintron, and what was funny is you would put such a big surge in the valve spring. The coils would be clashing, and it wouldn't have any load to close it on the closing side. I mean, you could flip that thing over and run the slow on the opening. Sometimes we get masters on backwards, and they'd run better. And, we learned a lot. I mean, the Spintron, just any preconceived notion that you can have, it can show where you're wrong in some application. So, yes, I learned something. We have 2 Spintron cells that run almost every day, and I don't think a week goes by that one of those things doesn't prove to me that one of my good ideas was bad or one of my bad ideas were good.
Wow, that is mind-boggling to know the amount of testing that goes on with that stuff. Wow.
Yeah, and what we can do we use the Spintron just to drive the dummy crankshaft in the valve train gear. We actually have National Instruments data acquisition. So, I wish I could send you a picture of it, but like I have a valve spring on my desk that we have 4 strain gauges on the outside of the spring itself. We also may run a load cell under the spring. We can run strain gauges on push rods. We can run strain gauges on rocker arms. We can run high-speed video. We can run high-speed strobe. We can instrument this thing like Darth Vader's bathroom. There'll be wires. It's not uncommon for us to have, just a pile of wires coming out of the Spintron cell back in. Sometimes they'll be running into the motor, and you just see a wire just disappear in the Spintron cell where it got caught up in the push rod or camshaft or something. It sucks it all in, and there's wire cutters trying to get it out. So, the Spintron is just amazing. We used to have 2 dyno cells and 1 Spintron running. Now we have 2 Spintrons and 1 dyno, and we've got 2 backup Spintrons across the street. So if one of them goes down, we can, they're all 75 horse. They're, AC drives. They're wonderful pieces of equipment.
Wow. Could you imagine that, the amount of data that they're collecting now? I mean,
no.
I've got good friends in the OE world that really are jealous of the resources we have at Comp, especially with the freedom we have to use them. Like most of their spin cells, they're stuck on durability cycles, which are almost like a form of torture for an engineer because you're just waiting for something that you don't think is going to break to break. Where we're doing very little on durability, and most of what we are doing is really research with our cells, and it's a lot of fun.
Well, this research is what drove, things like large diameter cam cores, larger diameter lifter wheels. Absolutely. Double taper push rods. All the advancements that were made in this industry are the result of data. That's where it came from.
It's funny. Like one of your questions I saw on Facebook was about picking rocker ratio. Mm-hmm. You bring up the push rods, and that's an interesting thing. Is that a lot of times we're picking ratio. We're actually rocker ratio. I'll have to find out how much room the port has, and the block has, and the head has for a bigger push rod, because the stiffness of a rocker arm goes up as the stiffness of basically any beam. The stiffness it has in bending goes as 1 over L cubed. Cube terms kick your butt. They're the ones that make it so hard to go 500 miles per hour on the salt. They're the ones that make boats go slow. They really, anything that's cubed, where when you increase something a little, it can increase a lot. That gets you. So on a rocker arm, if you look at the distance between where the push rod goes into the wheel on the other end, if that's the overall length, if you make that longer, as you make that a little bit longer, it gets to be a lot less stiffness. So if you think about it, on a rocker arm, if you talk to somebody at Jessel or T&D, they're going to tell you that you have to have a certain length between the trunnion, the center of it, and the tip, both to clear the valve spring and to keep the wheel from going off the end of the valve. So that distance set. Well, if you make a 1-3 rocker ratio, that means the back end of it's going to have to be longer than if it was like a 1-8 ratio. But going to that 1:3 ratio, now you've taken your stiffness out of the whole system by making the rocker ratio too little. But if you make the rocker ratio really high, like a 2-to-1 or 2.2-to-1, then all of a sudden your push rod's coming into your rocker arm on the backside at a really weird angle. So you're getting forces that aren't going perpendicular, forces that are going into the stand or out from the stand, depending on how you set everything up. And you don't want that either. You know what I mean? You really want to push 90 degrees. So if you look at somebody that has a really stiff push rod and camcore in it, they can probably get by with a little bit less rocker ratio, maybe a 1.7 or 1.8, where somebody who has a limited push rod in it, they could get by with a higher ratio, like a 2-to-1 if they had a really stiff push rod. But if you had a flimsier push rod, you'd have to go in there and back off maybe to a 1.7 or 1.8 because the forces on the valve are multiplied by the rocker ratio.
Yeah. One thing that's all great info. One thing I've always wondered, because I've seen it in practice, we used to be very conscious of both sides of the valve train with regard to weight.
Yes.
And it seems like the push rod side, that has kind of gone out the window because, I mean, we make push rods and you guys make push rods, obviously. And, and I've seen push rods that weigh a pound and they do nothing to anything but stiffen everything up and make more power. So
right. The one thing, there's a little paper that I wrote, and it's a tiny one, but it's about system stiffness. And it's basically about when you make a change to measure your lift with the big spring, with the real spring you're going to run. Say you run a 1,000-pound spring. Check the lift with the 1,000-pound spring, and then check the lift with the flow bench spring. And then you can check and see what your system stiffness is, because the difference, if you take the difference in load, so 1,000 pounds versus 0 pounds, that's 1,000 pounds, and the difference in lift, say it's 40 thousandths difference in lift, you can calculate the system stiffness. It's just the difference in weight over the difference in lift. So what happens is if you have a really stiff system, then it probably doesn't matter a whole lot on the push rod, stiffness. But say if you build the, as far as if a really stiff system might be one that you need to make the bigger push rod in, but it depends on the loads it's going to experience too. What I generally recommend customers to start with is figure out the biggest diameter push rod they can put into an application with the port, and then play with the wall thickness on the spintron. And it has been, sometimes we'll see that, in a pro stock deal, they may have a 200 wall push rod, a 200 plus wall, a 180 and a 165, and a 125. And you really don't know for sure on that big push rod. The 125 is probably not going to be the right choice, and the 200 and something is probably not going to be the right choice. But you might see that some of them like 165, some of them like the 185s. So it's not as intuitive as you would think. But if the rocker arm's flimsy, then putting a super stiff push rod in it, it's kind of like if you've ever read the book about the law of constraints, you have to find your Herbie. What's moving around? What's causing the limit of your stiffness? And so if the rocker arm's not very stiff, you don't want to throw a big, heavy, stiff push rod in it because that's not going to do anything to help you. You're going to need more valve spring. Lastly, if you're already oversprung, though, say you have more spring than you really need, that little bit of weight on the lifter or push rod may actually help because it may help throw everything over the nose, the high RPM, instead of letting it go up and crash. We call that, on the Spintron, we call it McDonalding, which I'm probably going to get sued for someday. But it sounds better than like the plumber crack look on the, when you have the cusp over the nose. It's just ugly, and it's ugly in so many ways. And that's the guys you see that like break lifter wheels and spall needle bearings and roller wheel axles, and you see the tip of the camshaft start to right around over the nose of the cam. You'll start to see it spall there. When you create those impacts, you create the very high Hertzian loads, and that something's going to fail.
Now, I want to point out that I did get that word right. You know why I got that word right? The first time I heard that when we were talking about flat tappets. That is... Okay,
yeah, that's the one, the Hertzian loads. And that's the thing is, when you look at surface stress, there's a great book on different, cylindrical bodies versus cylindrical bodies that are oiled and the surface stresses them and things like that. And it can get kind of crazy. So, it is interesting to look at Hertzian loads because the Hertzian loads are subsurface. And that's when you see camshafts that look like a highway where it's pitted out, that's when you've had those real high surface stress. And you have cracks that form below the surface and they join together and they kind of run around. And then you just have flakes of the camshaft come out, or flakes of the lifter wheel come out, or flakes of a rocker arm tip come out, like in a GMLS application from high Hertzian stress.
I would think that anybody that's looked at competitive roller camshafts in a racing environment sees that like you can see that like there's just like the cams eroded. There's just pieces.
It looks like alligator skin actually.
Yeah.
Alligator checking.
Yeah, and that's never that's what we're always trying to do is figure out how do we reduce stress. Like all of our roller cams, just I think about 2 years ago, we started it in the 24-hour Le Mans race applications, and then it went in Australian supercar. Both those have high cycles. We started to put a very, very slight crown on all our roller camshafts for those applications. When I say slight, I'm only talking a couple of tenths from the edge of the lobe to the center of the lobe, then back down to the other edge. But it was a very large radius that we ground with the CNC dressers. And now that so many of our camshafts, probably 80-90% are CNC ground, now all of our roller cams have that slight convex radius ground into them. I mean, it's a tiny amount, but it really matters because that keeps the edges. A lot of the roller cams you'll see will actually fail on the edges. So we've done a lot of work on surface finish. We've done a ton of work measuring the profile of the cam, and now we actually dress with a little bit of crown in the roller cams.
Okay.
There's a ton of stuff going on with that.
I think that like this could probably like knock one of the questions right out. Like a guy wanted to know if jerk was specifically what did he ask? He asked for jerk and he asked for spring pressure was hard on lobes.
Generally they call me the jerk, but it's the basically if you look, cam design's just a big calculus class. You have your lift, which is your function, your velocity, which is the first rate of change, your acceleration, the second rate of change. Jerk is the third rate of change. Jerk is equivalent to can be thought about as the impacts that you put into and take out of the system. On the opening side, so if I have high positive jerk going to peak acceleration, that puts impact in the system. Now, since there's lash, there's already impact that's coming in from that too. A lot of times when you see high negative jerks, one of the things like Harvey was one of my mentors, and Harvey Crane used to help me all the time. I think he was actually mad at Gina Zell, so he'd do anything he could to help comp, but that's a totally different story. But Harvey didn't like high negative jerks because he could see that led to separations of the components. So if you went from peak positive acceleration toward peak velocity, if you think about when you're at peak positive acceleration, you're on the gas pedal. And after you reach peak velocity, you have to go to the brake pedal. And how quickly you transition, imagine road racing, going from full throttle to full brake, how quickly you made that transition would lead to separation of the components. And he thought high jerk rates, and he would say anything over about negative 403 inches per degree squared was a high jerk rate. And he'd say high jerk rates, especially on the opening side, would lead to separation and crashing. And I was always amazed because I was brought up on a Spintron, and so I could actually see all this stuff. Harvey Crane was doing all this like pinball wizard by looking at camshafts that came out of engines and everything. And it's one of those things that some of the things you go to Spintron and find out, hey, that's totally wrong. And some of the things you go to Spintron and go, hey, it worked just like he said he would. And that was clearly one of the ones where he was very right.
That's pretty cool.
Yeah.
So he was obviously a smart man also.
Harvey was amazing. I mean, just such a. He came one of those big guys. I don't know if you've ever been around Harvey, but he's a giant of a man. Probably 6'6", and had a personality that was bigger than he was. And he'd come in and he was just so boisterous and so strong and so intimidating. But in the real world, he's one of the most kind, gentle, caring people I'd ever met in my life.
That's pretty cool.
I was by his house just right after his wife Maxine died, and and it was just the human factor. All these people that we grow up admiring and thinking are the world of, we get to know them, and a lot of times they're actually even better people than we'd imagine, but they're just real. It's kind of cool.
Yeah, that is cool. Very cool.
Yeah. But jerk is the rate of change of velocity, acceleration. So as you put high jerk in, that's changing acceleration quickly. Negative jerk, you're taking acceleration out quickly. And jerk leads to high impact. Jerk also usually leads to higher Fourier terms. So when I say Fourier terms, there was a French mathematician that said basically you can create any curves through a number of sines and cosines. And so that's the Fourier sequence. You can take any curve and look at the Fourier spectrum of it. When you have high jerk rates, that creates high frequency terms into your valve train motion. So you're inputting, say, every four-stroke motor is going to have high fourth order terms, high fifth order terms. But when you start putting in these high jerk rates, you'll throw up something maybe in the 10th, 11th, 12th order. And that means that at 10,000 RPM, the valve train for a few degrees thinks it's going 13,000 RPM because it's the 13th order.
Wow.
Yeah, and those high jerk rates lead to high Fourier terms. High Fourier terms excite the spring at lower RPMs. So we generally want to try to keep the jerk rates low to keep the terms that we're inputting into the system low.
Okay, got it.
I got that too, actually.
Yeah. Well, I told everybody Google's going to be your friend.
Yeah.
Because you're going to... going to be a lot of stuff here that you're going to want to be like, okay, let me see how I can apply this, and hopefully that's how everybody learns.
Right, and really, if to look at the jerk rate of a camshaft, like some cams can be fairly smooth. Like there used to be there was a cam series called a low harmonic cam, and I always thought it was kind of funny because by low harmonic, what they did was limit the acceleration. And Harvey may have actually started this, so I mean, I'd say the guy's a genius, then I trash on one of his designs. But the low acceleration designs were really good, but some of the guys who ran them in boats would start breaking locks and things like that. And what was going on is this was a high jerk rate, so the impacts on it were actually heard, the high impacts of the system, the high frequency of the system. In a marine application, you can find a really bad RPM, a bad harmonic.
Yep. And sit in it.
Right, and sit in it.
Tear everything up.
Boats can have 70-gallon tanks, and the radiators are a couple of million gallons at least.
Yep.
So, you don't tend to overheat or run out of gas. So they'll sit at RPM, that V cube term again. The drag goes up as velocity squared. So, you might be going at within 50 RPM for 30 minutes straight. Those guys would break locks with a quote-unquote low harmonic camshaft. It was because it was a very smooth cam. It had big major intensities. It was a soft cam, but it had high jerks, and that put a high frequency.
Well, that actually comes to a question that somebody asked me on the podcast, and I answered, and then it was somebody else contradicted and back and forth. Have you ever seen a camshaft where too much acceleration, or intensity, as long as the cam was stable, did intensity ever hurt power output? If you could maintain stability.
On the exhaust side, some of the low-intensity camshafts are very header sensitive. If you look at most of our catalog camshafts for drag race applications, the intake lobes will be in that typical 30 to 36 degree major intensity, but the exhaust lobes will be 36 to high 40s major intensity. And people go, why do you use these soft exhaust lobes? The exhaust valve's lighter. Well, Bernoulli starts playing a point when you start going with really fast, especially exhaust closing. Let's focus on exhaust closing for a second. The piston's coming up. It's pushing the last little bit of exhaust out of there, so the exhaust velocity is really high. And if you put kind of a long tail on the closing ramp on the exhaust, you'll get more time where you have high velocity of the exhaust leaving the chamber. Now, you think that the back of it, the pressure in there would be hurting you more than velocity would help. But because that high velocity of the exhaust valve seat may be very close to the intake valve seat, you can actually get a low pressure right around that exhaust seat that starts to pull some intake in early. And if you can start moving intake in the chamber, say 30, 40 degrees before top dead center, instead of having to wait for the piston to start moving really fast, 50, 60, 70 degrees after top dead center, it gives you a much longer intake stroke. Probably the reason why you guys all remember when people, put the longest rod you can in there.
Yep.
And then you look at a typical pro stock, it's a very, very short rod. So looking at that type setup, the reason short rods work so well is they give more time at it gives more time. You reach peak piston velocity sooner, so it gives you more time to pull on that port. So thinking about sometimes a softer exhaust can definitely give you more time to pull on the port. But generally on the intake side, I almost always see a faster camshaft. A camshaft that's quicker off the seat, gives you more area under the curve, just gives the port more time and it's better, better area. So I don't often see, I can't even think of many places I have seen the slower cams work better. If you think about it on the opening side, you may see something on the opening side where you can get more duration in on something that's very limited on piston to valve clearance by going to a softer opening.
But, yeah, that's a fair point.
All right, so there can be there's some tricks we do there on the pro stock side that I don't want to say don't work because they do. But pro stock's a weird world. Yeah. On the closing side, it's kind of interesting because if you look, one of the things that some of the NASCAR guys used to look at back in the 90s and 2000s was you tried to get the earliest intake closing you could, but maximize the lift at bottom dead center on the intake. That BDC lift, think about how much, when you start getting to peak power and beyond, how much air is still coming into the chamber at bottom dead center. So if you go to a softer closing, if you've got a certain closing point that you do, just imagine the slope as you start laying that line down, you get less and less lift at bottom dead center. So I've never seen for a given intake closing point, the more lift you can have on bottom dead center, the more power you're going to make. Almost always.
Gotcha. See, we used to look at a couple different points because we didn't have the benefit back then of a cam doctor, to really get an idea. So we used to look at like 20, 50, and 200. We always used to look specifically for the flat tap. I was always looking at 200s because we had so little to work with. And but that's a whole nother story. And those guys don't want to hear about flat taps anymore. Now antique.
Yeah.
No, but we learned so much. The thing is, the flat tappets were hard, and they gave us some. They really forced us to learn some of these things we're talking about. I don't want to have to ever go back to the flat tappet world because going off the edges of lifters and the small nose radii over the top. I mean, it gave me more sleepless nights than I ever want to remember.
Oh God, lifter crown and everything.
Oh, good. You had lifter crown, lifter chamfer, lifter bore indexing. There was 1,000 times. Do you run the cam tunnel full of oil or do you run it half full of oil?
Yeah.
Squirt in there. I mean, where do you put your returns? How do you do your standoffs? Where do you flow the oil back? There's 10,000 things we had to learn on the flat tappet cams. But, the other thing is you just couldn't gorilla it because you couldn't putting load into it. On a roller cam, you can often, people go, oh, I don't want to be, 100 pounds, 200 pounds too much over the nose because that's going to take so much power out of my engine. And the thing is, you find out on the Spintron that, hey, I put 100 pounds more open load on it, and you go and test it. It's one of the things you said, well, what do you believe, and then you test. Well, you find out that because, you're fighting against that spring on the opening flank opening, but then it kicks you back on the closing side. So the drive horsepower between running a 500-pound open, a 600-pound open, a 700-pound open spring on a V8, probably in 5 horsepower difference between the max and the min.
Right, because it's working for you on the other side of the lobe.
Exactly, it's working for you on the other side of the lobe. I've had guys come here countless times and like they've never heard of Ducati, and they try to explain to us why we need to have desmodromic valve motion, and they show me a torque wrench measurement turning the cam over and how turning the crank over and showing how much torque it takes, and they're going to pick up 100 foot-pounds, by and you're just like, no. It doesn't work that way.
It does not work that way.
I'm like, here, I've got this fluke voltmeter. Why don't you look and see how much power? We've got a power gauge on the Spintron on the AC drive. Look how much power it really takes, and it's shocking at how little power it takes to run one of these engines at a steady state.
I think that actually kind of knocked off a question too, because a guy was asking about valve spring.
And spring pressure is very, very misunderstood.
Yeah.
So many people think that like high spring pressure is horrible on everything. And while it's, I don't believe you should have anything that you don't need, but I've seen some crazy spring pressures and rates.
No, it's like, it was very, very hard to build a competitive, before they put the RPM rule into Pro Stock, and I love. Yeah, I consider, now this is going to be funny because go back to ballet. Yeah, I consider the NASCAR approach as the ballet dancer approach. Try to totally finesse it with as little load as possible.
And it's a little, yeah.
And these are, those are 1/200 diameter springs, and they might be 70, 80 pounds on the seat, stuff for restrictor plate. Not much more for open, might be 150 or so.
Yep.
Very, 500 rate springs, little small guys, And then you look at NHRA Pro Stock, we call those the gorilla springs because they're 550 on the seat, 1,500 pounds open.
Yeah.
But we tried all kinds of, we tried to do what I consider was kind of like the modern, linebacker or rover type deal, or you tried to get the most you could in an in-between type setup. Cross-pollinate the ballet dancer and the gorilla. And we do some things like that. And it was really hard to build a competitive NHRA Pro Stock that wasn't close to 1,500 pounds open.
Yeah.
But you had to think these guys were trying to go 12,000 RPM with over an inch lift, so I used to call them like quarter race cams, like 1 inch and a quarter lift and 12,000 RPM, was what they were all after.
Yeah.
12,500.
They're actually bigger than full race.
Mm-hmm.
It's crazy.
Yeah, right.
It's crazy.
Definitely bigger than full race, yes.
Yeah, we had a lot of that with super stock stuff because of the valve types and what we had to use and how heavy that stuff was. That was
super stock running the steel valves. I mean, there is. I mean, if you race a super stock Hemi, you've got to hate your money.
Mm-hmm. Yeah.
God bless every one of those customers. Because my kids get to go to good schools because of it, and I live in a nice house. But, it is a way to absolutely despise your money.
It's true.
Yeah.
It really is true.
Yeah.
Or a B-automatic Corvette with 3/8 valves.
Yep.
Oh, goodness gracious. I forgot those even exist.
Yeah. Well, they hate their money worse, I think. Maybe. Maybe not.
Those guys are running the tool steel cams with DLC coated, so they've got a $1,200, $1,500 camshaft. They've got a $1,600 set of lifters on there.
Yep.
And it's all for a lift rule if it's instead of in B stock, instead of the stock eliminator. Those things are crazy. Yeah.
Yeah, they are.
Yeah.
I don't think people really understand like what stock and super stock. I mean, what you're asking one of those motors to do.
No.
I mean, it's
it's amazing. Really, like one of the things we're talking about cylinder heads and camshafts and stuff is one of the things I have a little rule of thumb is horsepower per CF. I look at horsepower not per cubic inch, but horsepower per CFM, because I figure I can always turn more RPM. If you give me a little bitty engine with a great head, but the best motors in the a good endurance motor makes about 2 horsepower for each CFM of cylinder head flow. A super stock motor though probably makes 2.5 to 2.8, and a comp eliminator motor probably makes 2.7 to 2.9, and the pro stock stuff's really close to 3 horsepower per CFM.
I've never heard that. Horsepower.
Yeah, well, just think about. I mean, if you run it through your head real quick, you start looking at how much horsepower can you make with a 300 CFM head? Okay, well, 600 horsepower is a pretty good,
Yeah.
And then you go, well, can anybody make 900 out of it? Well, no, it's about 780, 820,
Oh, it makes
like
perfect
that.
sense. I just never.
Yeah, and it works like a champ, but it's the most beautiful thing, because when somebody goes, when they're asking you to pick a camshaft, and eventually we'll come to like a horsepower goal, and I do the quick calculations, and they're asking for 4 horsepower per CFM. I'm like, well, how much nitrous or boost are you running? And they always get mad at me and stuff like that. It's probably why I'm not allowed to talk to a lot of customers.
Well, I was glad you guys talked to me because it was a big influence on our flat typer program. And I still, and all the guys I know, you don't want to hear about it. I'm not going to bring it up anymore. I promise. Well, let's try to knock off some of these things. Like guys were asking, I think one of the ones that I was really interested in is as far as like the hydraulic lifter stuff goes. I know, and I said it on there, I know zero about it because it's never been something I've had to do. Are there design constraints when you put a hydraulic lifter in place, and what are they? I mean, I heard a little
Well-
piece when you were talking about like lifter and the amount of cushioning in a lifter because of available space and aeration of oil. I got to hear a little bit of that, but
Right.
it's just a subject that I think a lot of people are confused on.
Well, I keep going. I've been all over the map on my beliefs on hydraulic lifters. I mean, for ease of operations, there's nothing that touches it. As far as setting in the middle and go, for 90% of our customers, a hydraulic roller lifter is a great decision. The thing is that Harvey and I used to go around and round and just about get into fistfights because he believed that because of aluminum blocks that some endurance applications, especially stuff like 24 Hours Le Mans, would be won by a hydraulic roller camshaft. And and honestly, I think Aero Racing won the GTD class with the hydraulic roller camshaft in the 24 Hours of Daytona. So the GTAM, I'm sorry, the amateur class. They won that with a hydraulic roller camshaft. So it can be done, especially when you have aluminum blocks, aluminum heads, because it adjusts and keeps in that range, so you don't have to worry too much about the last change of temperature, and you don't have to worry about valve seat erosion like you will on a solid. You also don't have to worry about temperature changing. Like one year we had a couple of customers, a cold front went through Daytona, and they were running really tight lashes, and they went out there and whacked the throttles, but loaded the motors before the temperature got going on and got up, and they torched a bunch of exhaust valves because of it.
Mm-hmm.
So the hydraulic roller, you don't have all that mess to go with. So Harvey loved the hydraulic roller. The problem with the hydraulic roller is that it's got more sophisticated tolerances than any other component in the engine. The bore of that lifter versus the piston in that lifter is held tighter than anything else in your engine. And then you have all the ball check valve, you've got all that mechanism in it, you've got everything going on. And then all of a sudden you put motor oil in it that changes viscosity with temperature, and it's in an environment that can't help but get air bubbles in it. So, there's always going to be some cush there. So I think if you're racing competitively, that if you can, even if you're running an endurance application, if you have world enough of time, you should take the time and go in with the solid roller, because you can just push on it harder. And like you said, the faster valve, what we went back to, started with the intake thing, the faster I can get that intake from closed into the sweet spot of the cylinder head flow, keep it there the longest I can, the faster I can get it from there back down to the seat. If I win that race up and I win that race down, I'm going to win the race. And, you can just push it harder. You can run higher accelerations. You can run, higher jerk. You can run higher harmonics with a system that's stiffer. And you're always going to have a little bit more stiffness because of the innate cushiness of a hydraulic roller, because if not, we can get into are fluids compressible or not, and I can have great arguments between engineers and physicists on that. But in the real world, a hydraulic lifter is always going to have some cushion to it.
Yeah, because there is always present in oil. Always.
Yes.
Air is always present in oil that's in an operating motor.
Mm-hmm.
The crankshaft is the best whipper-upper of air into oil that man has ever devised.
Okay, so he's gone from whipper-upper to Hertzian.
I want to point out that I say some
am a
things.
physicist, okay?
Yep.
I
man.
am from Mississippi, so you have, I don't know if you ever watched Blazing Saddles.
Oh, yeah.
Yeah. But if it's not that man with a gun and a badge, it would be a redneck with a nuclear physics degree.
Okay, got it.
I was applauding that, by the way. I wasn't making fun of it.
No, because I've said some dumb shit like that, and people have been like, "What?"
But you're you.
I know, but
He actually used them both properly.
but that's awesome.
I know. I was complimenting. I said that. That's awesome.
Yeah.
So on the hydraulic tappets, and the one thing that maybe it was answered and I didn't quite get it, but one of the guy asked about spring pressures. Do they actually utilize less pressure because of design limitations, because you're trying to keep the stiffness? Is that where that was going?
On a hydraulic roller lifter, Billy Glidden was probably the first guy to ever run like 750 pounds open on a hydraulic roller lifter. And it worked so good that the NMCA made it illegal the next weekend, because Billy was never good at not showing his hand when he had everybody covered. You wouldn't want to win a race by a few thousandths when you could win it by a second, right? But the problem with hydraulic roller lifters is that there's really none that the bottom end, the link bar mechanism, everything like that, nothing that I've seen on the hydraulic roller lifters. And we made some special ones, but most of them weren't designed thinking about 700, 800, 900 pounds open.
Gotcha. Okay.
So there's just, even if you could make the piston hold up to that type of loads, and I've seen some really cool stuff on the diesel side where they made great internals on a hydraulic lifter. Even if you could make the internals good enough, you'd have to really redesign the external limits of it. You'd start seeing a hydraulic roller lifter with a 850 or 950 diameter wheel in it, and a bigger bearing, and all that kind of stuff too.
But the limitation isn't the fact that it's hydraulic.
Right. No.
Yeah, I didn't think.
The big limit of the hydraulic is how do we get the oil out of it? Is out the air oil separation. So a dry sump hydraulic would be the right way to go with a great big separating tank. But not to me, the hydraulic rollers I see on the street have that little trick hidden behind.
Yeah, not too.
Got it.
Yeah.
All right. Well, you had mentioned another key thing, and you were good enough to actually post what I would call a translation sheet to allow you to go from wheel diameter to, camshaft core to figure out exactly what you need to stop that. Why don't we talk some about that? Because that's something that I think even at one point we got a camshaft and somehow or another a wrong variable was plugged in and it actually worked out better. And it happens, and that we used to have salesmen that cheated all the time. They knew that I made all these different designs for different journal sizes, and if they wanted to make it a little spicier, it'd be kind of like a Thai restaurant where you go, I want the pad Thai, but I want it extra spicy. So they'd take a smoother lobe and then have it ground use a 900 base circle master and let it grow, knowing that it would grow less at 20, more at 50, and the most at 200 by putting it on the wrong journal size. And the problem with that is that I had to do all kinds of conversion after it worked to figure out what they actually did. But it's been nice because all of that basically led us to go, hold on, let's design what we want. Let's make every valve motion, every tappet motion we want, and take that, work real hard with it, and then get that motion instead of trying to cheat it. If you look right now, Comp Cams has a little over 20,000 different unique lifter motion designs, meaning here's, like when you check it on the ag coal, this is what we want, the little disc, how we want it to move up and down. But if you start to look at the number of actual different masters we have, it quickly becomes like 200,000 something, because you have to have, the same thing for each of those 20,000 designs. Okay, we have that for a small block Chevy, we have it for a small block Ford, we have it for an LS, we have it for an LS with a 850 wheel, we have an LS for a 950 wheel, we have it for a 60 millimeter, we have it for a 70 millimeter. So, it's led to this like exponential growth of designs, which would have killed us if we were still using Burkos with plate masters, because it's funny, when I started at Comp, we had 2 pieces of 4x4 pegboard with all the masters hung up on hooks on it. I was going to ask you if the big masters are still used, or now we've gone away from all that and gone to numerical methods.
Well, it's funny because, so they used to be up on 2 pieces of 4x4 pegboard. Then we took a little office and we put this sliding down. We got up to 2,000 or 3,000. Then we took over another office, and we've basically run everybody out of offices in the shop. They're all full of masters now. But even that wouldn't let us. You can't set aside 1,000 square feet and stock enough masters to be able to do what we want to do. Mm-hmm. So what we wind up doing is going for all the stuff on CNCs, every overhead we grind CNC, every pro stock we do CNC, every NASCAR we do CNC, even all the LS and things like that, they're all done on the CNCs, so we can get the right tappet motion and don't have to cheat anything.
Gotcha.
Because when you cheat, you always change the accelerations. When you change the accelerations, you change the harmonics. When you change the harmonics, you change how. Imagine a camshaft profile and a valve spring are like dancing partners. They're, one of the camshaft is, if you look at differential equations, the camshaft is the forcing function, and then the valve spring and the valve train is your response function. Or if you look at it, like my wife does in all movies, one of them's Fred Astaire, one of them's Ginger Rogers. Ginger Rogers has to do everything in heels backwards. So if you change the driving function, you change how the valve spring responds. And so it's not just a change in duration, you've actually changed the frequency response when you change that geometry. So we want to nail that geometry the best we can.
Mm-hmm.
So that's a real long answer, but
Yeah, well, it's kind of funny because that's what happened. We got something. It was like Jesus, I can't even remember what it was, but we got it on a Ford Camcore, and it had like an intermediate size Jessel keyway lifter, and the thing behaved beautifully, and we liked it. We got another one, and it was completely different, and we're like, all right, something's wrong, and we had to send the one in to figure out what was done to get to where we got to.
No, it's funny because there used to be an RT1 and an RT2 for our RT series, our popular RT series in the Craftsman truck when that first came out.
Mm-hmm.
And one customer, what the guys at the shop would do is usually they grind the 50 millimeter was right in, but RT2 is for Ford, so that's for a 2055 or something like that, Critical Journal. And the S was for a 1968. So the 50 millimeter fell in right below, 1968 versus 1868, 1968, and 2055. So we had the 1868 and the 2055, but not the 1968. So what they would usually do is grab a 2 degree smaller RT to grind the duration they wanted for a 50 millimeter. Well, one time, which made it a little faster, one time somebody grabbed a RT2, which was a Ford that's 2 degrees bigger, and used that to grind the 50 millimeter for this Chevy customer. It was probably somebody like Hutter, I'm not sure.
Mm-hmm.
But the crazy deal about it is this one they ground with the RT2. That particular master had sat around a lot, and when they would sit around a lot in our shop before we had air conditioning, the masters would rust. So every time they rusted, they'd go and polish them. So because this one wasn't used very much, it had been polished a lot. So it was a RT2 that had been polished a lot that shrunk a lot. And this thing was like the magic camshaft. So I had to get it back and measure it and figure out what's going on. And we came up with our RX series based on what that RT2 looked like, ground on a 50 millimeter after it was over polished. And then we put a little bit more oomph back into it, added a little bit more lift, and added a little bit more at 200, but took those ramps. And so the popular RX ramps, which probably won as many races as anything Comp has ever done, was actually based off of a mistake we made by grabbing the wrong over-polished master.
Yeah, the RX lobes were what we used in a lot of the big block circle track stuff in the Northeast Star
absolutely.
stuff.
They were like the only thing that would last on some of that stuff. They were great pieces. So yes, one of the best lobe families I ever designed came off a mistake.
That's really amazing that's to hear the backstory of this lobe that we like so much. That's really neat.
Yeah, there's the one of the other lobes that's really popular. It's won a lot of races too. Is our HXL series, and since you know Gordon, you'll love this one. Gordon and I are headed to lunch. Now, Gordon and I are kind of like the coyote and the sheepdog, and we fuss about which one's the coyote and which one's the sheepdog. But we fight more than any two people at Comp Cams during working hours. But once or twice a week, we'd go out to lunch with each other. And, we're really good friends when you leave the parking lot. But one time as we're leaving the parking lot, Gordon looks at me. He goes, those Dash 8 profiles that John McWhorter designed, they really good. I said, yeah, they were really good. Because John was really above his time, wasn't he? Yeah, John was way above his time. Yeah, I bet it was because they sure kick anything you made right in the bleep even after 20 years. It's the quietest lunch you've ever seen. Not a word was spoken after that. I'm making it a little less colorful than he actually said.
I'm sure.
So we got back from having a little Chinese lunch, came back. I went straight to work on the HXL series, and the HXL series is probably won more super stock races than anything we ever had, and also extremely popular in the sprint car type applications and a lot of the dirt track and different different applications. But yes, some of the best lobes were either from a salesman insulting me to no end, or from just mistakes we made. So both of those applications work well.
If he's a good salesman, that was motivation, not insulting.
Absolutely. Gordon was playing me like a violin. He knew exactly which string to hit,
and that was okay.
No, it was fine. He just likes it. He jokes with me that whether he wants a really aggressive cam, he tries to order it get me design it before lunch. If he wants a real smooth one, he tries to get me design it after I've eaten too much. He works me every which way there is.
Good for him. Hey, before I forget, because Mike's working on his next question, I just want to mention and thank and shout out to Ben Strader from EFI University. He was instrumental in getting us in contact with Billy. Although I've called you a couple times, but you're busy, we're busy, and Ben kind of put it all together. So thank you to him. I know you guys are pretty tight, which is cool too.
He's one of those guys that you hear about and people go, oh, he's a great guy. He's a great guy. He's a great guy. Ben is really that type of salt of the earth guy that you just love to spend time around.
Yeah, definitely one of the good ones for sure.
He really is a great guy.
Yeah, what happened is when somebody said we need a cam guy, I said, I know who we got to talk to. And I called Gordon. And I mean, hadn't talked to him in 100 years, and I was hoping he was still there. And I guess he told me he's like kind of semi-retired.
He was probably making fun of Billy at the time.
He's Professor Emeritus now.
Yeah. So he had put somebody in touch with me. He said that, Billy would be ideal for this. And he put somebody in touch with me that wanted to listen to samples of the show. And at that point, I think we only had 2 or 3 that were like guest interview, good technical shows.
Well, and higher end stuff.
Yeah. And I'm like, wow, what do we do here? So we didn't send him anything until we got a little further along. But yeah, no, it was, I'm glad this all worked out. Yeah. I guess from what I understand, you're about out of time. You have a little bit of a deadline, which is fine.
Yeah, my bride wants me home at some point. Yes.
Well, I wasn't going to say that, but
hey, it's okay. Being happily married is not something I'm embarrassed of.
There, good man. That's good.
I'm trying to think if we got any more questions here. This is actually probably a good one that a guy asked that I didn't really know how to answer. Is there any lobe or camshaft theory behind different types of fuels? Like say, I guess,
methanol
pump
versus
fuel,
pump
methanol,
fuel,
maybe nitromethane. That might get a little too crazy, but I mean, there are normally aspirated nitromethane classes.
Sure.
Yeah.
Yeah, there are, and it's been, when John Force's daughter Ashley was working in the when she was getting her A fuel stuff, that was so much fun. Is Darian I mess up his name. I don't want to mess it, but it was getting to work with those guys was great and learned a ton, especially because then you don't have the blower to make the cylinder pressure, and you really need the cylinder pressure to make one run. So we had to play a lot with intake closing, a whole lot of new cam designs, things like that. Nitro burns really, really slow. People think it burns fast. It burns slow. But so you have to be really careful on exhaust opening if you try to open it too early. You just can't get it to move. That's the clearance on the push rod with Austin coil thing Scooter's talked about before, and that little deal that you viewed. But there's a ton of things that go on. Generally, we like to think at Comp that air is hard to move and fuel is easy to move. That's not 100% accurate, but it's at least 90, maybe 95. So we generally don't think a whole lot about the fuel. You will see that generally, if you look at an alcohol motor versus a gas motor, say you've got one guy building a very similar dirt track motor, one of them's gasoline, one of them's alcohol. You'll see us put a little bit more intake duration on the alcohol motor. That's more because we know that the alcohol takes up volume in the intake port, especially when it's in the up nozzles, and you want that evaporative cooling. So you want to put in a lot of fuel in the up nozzles because that will actually cool down your charge, and then trim more with the down nozzle. But it takes up some port volume too. So all of a sudden your head that you think is this much cross-section, you might lose several percent on cross-section because of the fuel volume. So the air is harder to get in. So just like you crutch, generally on anything normally aspirated, the better the cylinder head, the less duration for a given application. The worse the cylinder head, the more duration. So you'll see us put an earlier intake opening, a later intake closing with the alcohol because of the volume that's taken up by the alcohol. If it was direct injected, we wouldn't change it one bit from gasoline to alcohol. Direct injection system.
That makes sense.
So, there's very little. Most of the stuff, like you hear all the nitrous camshafts that we do, we actually change those more for torque curve tailoring than we do for actually the nitrous itself. The thing is, if you're making, if you've got an extra 500 foot-pounds that you can't get to the ground, giving away 100 foot-pounds down low to pick up 20 horsepower that you can get to the ground up high is a pretty good change. So that's why you'll see the wider lobe separation, a little bit more duration, a lot more exhaust duration on the nitrous. It's not so much that we need more time to get the exhaust out on nitrous. You need a little bit more time, but generally we're opening the exhaust early to give up some low end torque and gain back a little bit of.
Never would have thought of that.
And you know what's hilarious? Yeah. If this is like the internet dumbassery, if you look at this stuff, there's all kinds of reasons why the center lines are where they are.
Yeah.
There's 100 reasons. You can't believe them. I mean, I wish you could, but you just can't.
No, that sounds like the reason.
Yeah, no, it's
common sense.
Absolutely. We're absolutely torque curve shaping. A lot of what guys like Gordon do that makes the best guys at picking camshafts do is they're working durations to tailor a torque curve to an application. The best guys at cam selection, that's what they're doing. They're working that torque curve to work in that application as that vehicle be driven.
That's a fantastic.
So that's why they ask things about the vehicle that you think that the motor doesn't care. No, the motor doesn't care whether the vehicle's 2,000 pounds or 4,000 pounds, if it's a 3-speed or a 6-speed. But the dadgum, that where it's going to be on the torque curve matters a lot.
Hell yeah.
So that's why they're doing all of those questions about the vehicle, is to try to figure out what RPM they're actually operating at, and then tailoring the torque curve to work around that application.
You know what's funny? I've been on the opposite side of that, where I've been the guy being like, why is he asking me what this, what class super stock this is going to go in? Because he's trying to figure out how heavy the car is and what we're working against.
If Gordon asks you about that, what he's trying to figure out is how many seconds it's going to be, or how many hundredths of a second it's going to be on the converter during the launch and on the gear shift.
Gotcha.
Wow.
Because you actually have to have torque 500 RPM below where it flashes on the converter. I'm not sure why. It has something to do with accelerations, transients, and things like that. But if you're hurting there at peak torque, at that converter flash on a drag race application, if you're hurt there, you can't make enough horsepower up high to how the car will do poorly.
Right, to make up for it.
It will not do, for every tenth of a second, every hundredth of a second you lose in a 60-foot on a drag race car. You lose twice that much in the quarter.
Yep.
Mm-hmm.
So if it wants 60 foot, and if it stumbles every time it hits the shift recovery, there's nothing that you can do to make up for that.
Fantastic. Well, I'm sorry, go ahead.
I got to ask a question for Kevin, because Kevin is Kevin is a friend of ours that always helps us get gas. And I know you got to go, so we're gonna make this.
You're fine. She's really not gonna get that mad at me.
Okay. He wants to know about camshaft torsional twist, and is that the reason for the larger diameter cores, or is it overall stability because of just plain structure?
We've put hide encoders on both ends of the camshaft on the Spintron. I've heard a lot about camshaft torsional flex and everything like that. I haven't seen it much. I can't detect a whole lot on there. But what I can say is the cam bends a tremendous amount. If you look at the difference, every modern racing engine is over a 1.2-inch diameter barrel now. If you're not up in there with a modern pushrod motor, you're giving up so much. So if you see one of these with like a 900-inch or 1-inch barrel, that thing's bending like a kite in a whirlwind. And you'll even see that with that stiffness test. Just checking the lift, with the checking spring versus checking it with a real spring.
Yep.
You'll see that your camshaft bending is playing a major role in your overall stiffness, and you don't want that. Once you get up on a 5-journal camshaft, once you get up around 1,300, 1,400, it really is pretty stiff compared to everything else.
Mm-hmm.
You go to a pro stock that might have 9 journals, that system could probably be an inch 200, inch 250. Now, the torsional, as far as the cam twisting, that's not as big deal as like what we've done is put that same Heidenhain encoder on the front of the camshaft on like a running pro stock application at 10,000 RPM. When they go, every time the cam starts going up an intake flank, the belt system and everything else may slow it down to where it's only going like 8,500 RPM up the opening. And then when it goes down the roller coaster on the back, it might be going 11,500. The average RPM is 10,000, but there's tremendous torsional spikes. These aren't end-to-end torsional spikes. This is the whole camshaft speeding up, slowing down, speeding up, slowing down.
Based on lash kind of in the belt and the rest of the system.
Yes, right, and just the whole, right.
That's crazy.
Yeah, so it gets really, really crazy. So you see all kinds of things that people do to try to dampen out the motion of the camshaft. I think that's one of the bigger reasons that like the 70 millimeter often runs better, and people even play with like the 80 and 82 millimeter diameters in pro stock. I hadn't seen those do too much, but people look at pressure angle. They're looking at the bigger lifter wheels. Things like that is all to try to dampen out that torque on the camshaft to make those torque spikes and that speeding up and slowing down less.
That's amazing. There it is again, data.
Yeah.
Wow.
Yeah, I know, and I'll tell you that like you see these motors that are run complementary, just half a 4-cylinder. Somebody takes a pro stock motor and literally caps half the block. Well, that has to run a smoother cam because all those torsionals than you see on the on the V8 application.
Oh, they're multiplied.
So you could have like Carl Foltz build you a head for a 4-cylinder, a odd fire 90 degree V6, an even fire 90 degree V6, and a V8. And you could not, even though everything was identical in the motor, all billet motors, and exactly the same, head, valve spring, everything. You could run a much smoother a much more aggressive profile on the V8 than you could the 60 degree even fire. You could run a more aggressive on the 60 degree even fire than you could on the 60 degree odd fire. And the 60 degree odd fire would be a lot like that 4-cylinder just because all the torsionals you could see. So there's a lot of work in trying to dampen that in camshafts. You can see that this isn't a new deal. If you look in the 1960s, Cosworth Formula One motors, they actually had a brake and torsional balancing pucks on the camshaft.
Mike's got...
The daggum Brits weren't always dumb.
Yeah.
It's kind of funny. Like, I wonder if this is some of the things that, like, my dad saw in, like, the 70s that, like, we didn't really have a complete explanation for. Because I remember we were using a timing set before the belt drive was available. Because I was around when they came out and, when all that stuff started. And it came from Danny. And I remember that in all the super stock stuff, we always used a nylon timing gear, not a steel gear.
Mm-hmm.
Yep.
And it was from Cloy's, and there were 2 types. There was a wide and there was a narrow, and then there was a link type chain. And that was actually worth a chunk on a super stock motor on a dyno. And I wonder if it's all of this coming back around to what that data really was.
Yeah, one of your guys, I looked over at my computer screen. Jeff was talking about love happy accidents. Like the one of the coolest things, I guess I love the World of Outlaw type sprint cars because they just don't have many rules. And but we put one on the Spintron. This guy was wanting to up his game a little bit, and go a little faster. And we put on the Spintron. We're like, look at this thing, look at the data. Go, there's no way this thing lives. There's no way this thing lives. This thing's got to be tearing up. I'm like, well, what all parts you break? I said, I'm not breaking anything. I just want to go a little faster. And we're looking at that. There's no way it's lives. So we started thinking about, you look at the cover, and we've covered up the front of the camshaft. So we went and go, can we see your dry sump system? So we took his dry sump system, figured out how much oil he was running, took a little 55-gallon drum, put it in there with oil, used that as kind of like the dry sump system, and we're pumping oil through the pump. And the crazy thing was this oil pump on the end of the camshaft was this amazing dampener. And this thing that looked like it would have killed everything in 5 seconds, 8,500 without the oil pump, you put the oil pump on it, it'd go 9,800.
Wow.
You're like going, and you saw exactly what we're talking about. So I don't know with the guy who came up with putting a water pump on the end of a sprint car and the dry sump pump on the end of the cam for a gear drive on a sprint car was either the smartest person on the face of the earth or the luckiest dude I've ever come across.
I think it was the latter.
A combination of both. I don't know, but it's amazing because literally I think you could take the dry sumps. If you ran the dry sumps on a belt drive off to the side, half the world of outlaw guys wouldn't finish 20 laps before their valve train blew up.
Well, do they still run gear drives too?
Yeah, they
Yeah, I mean,
with
they're
that gear drive converting all those harmonics, and they
Right.
run fairly decent lash in there. If they ran that gear drive without that dry sump, it would kill everything.
everything. Yeah,
That's amazing.
Yeah.
So
Yeah.
the dry sump is working like a damper. Holy
It
crap.
is a cam dampener. And
And-
I've always wondered, man, how could we?
They
a
don't know
couple of
that.
my buddies who runs NHRA runs a pro stock bike, and I'm like in his camshafts flopping over the place. I'm like, can you run a dry sump off? you know,
Oh, that's funny. They're going to learn something. They're going to have to. The sprint car guys are going to have to listen to the show.
All scratching their head.
Yeah.
Damn.
Right. You know, it's just crazy that you look at that and go, well, that's the dumbest thing I've ever seen. Then you're going, oh, we can't get rid of that.
Yeah.
We tried to do some LS. You know, we have it for our RHS block. We have a dry sump, you know, attachment to go to the front of the block to run off the camshaft because it really does matter.
Wow.
Wow, that's something. And like, see, I
Yeah.
think that sometimes the guys found stuff, you know, like things that my father found in Superstock and things that, you know, other guys that were really pushing the edge for their time, that they didn't know why. They didn't have the data gathering that we have today. I mean, I sit here and just think about all things they can measure now and say, damn, I wish I could know that. That's amazing.
No, and it really is. You take those guys, you know, guys like Bob Glidden and Grumpy, the testing that those guys would do. I honestly believe that Bob Glidden worked so hard in pro stock that it made Jack Roush find something else to do and go into NASCAR.
I think you're right about that.
That
Yep.
he'd stay up. I don't think Bob ever slept. He was testing stuff. I mean, he would just, you know, test stuff and test stuff. You know, it was nothing for John Lingenfelter to order one camshaft of each firing order that we could possibly dream up.
Yeah, they would just outwork everybody,
Right, they would just outwork him.
as well as being smart guys.
They were truly blessed guys. They were amazing, but they would work like you wouldn't believe.
Yeah. Yep.
All right, so this is officially the last question.
Okay.
I know it because we had the first time that I ever used them was in this whole flat tap it up exercise. Somebody asked about the LSs and conical springs and why they seem to be better or the spring of choice over, you know, probably looking at something like, you know, like a big giant
the
spring
dual
of some
springs,
type.
There's the beehives, there's the dual springs, and there's the conical springs. And I mean, there's no way to make a double spring that has as high a frequency as a single spring with the same lobe. I'm saying load. Did I say lobe? Yeah, I did. But the same load. So if you want the same seat pressure, same open pressure, if you can do it with a single spring, it's just going to have a higher frequency, which is higher frequencies. We talked about Fourier earlier. You know, the higher frequency you put in the spring, the better. The problem is that a single spring has a single frequency. A beehive spring is really just a cylindrical spring with the last coil and a half, last two coils that taper down really quick. The cool thing about a conical spring, a true conical, is every coil is a different diameter and every coil has a different spacing. So each one has its own different frequency, and therefore it's extremely good at dampening out harmonics. So the conicals are amazing. The problem with conicals is trying to make them accurately each time. And you can go back to the 1910s, you know, 1912 chords, things like that. There's a lot of pre-World War I engines that had conical valve springs on them. The problem is you just couldn't manufacture them. You know, when you heat set a spring, it changes its pitch. So when you have different stresses from different diameters, different spacing, and you heat set it with a conical, it'll move all over the place. And then you get people that try to run a conical on a modern modern spring winder, and they'll do, you know, after you wind a bunch of them, you start running through heat set, and they'll move unexpectedly. So when we learned to start doing the conical, we had to you have to run a few springs, run them through heat set, see how they move, change the programming, keep going back and forth. And because the top coils move a lot more than the bottom coils. There's a lot of things of trying to equalize the stress between each coil, not the static stress, but the dynamic stress. So there's just a ton of work that went into the conical stuff. It's very difficult to do, but if you can do it, man, there's some magic there. That's what I run in my personal race car is a conical valve spring. And if if you're running low enough lift to use the conicals, I don't think we have any conicals we have a dual conical that go like 780 lift, and we have single conicals that'll go up to just under 700 lift. But if you're under that 700 lift, you can run a single conical. Man, those are awesome springs.
Yeah.
Okay. Good information.
Yeah,
All right,
I hope that makes some sense about the pitch spacing and everything.
Now,
we're sitting together in the same room. I could point and show you.
maybe someday. All right, I have the official last question. Can we get you back on the show in a couple months? Maybe continue this.
Absolutely. Yeah, I'd love to do it. And like I said, your guests, everybody that submitted questions both during the show and on Facebook, I really appreciate it. They were great questions. I'd love to get with all of them, talk about the difference between turbos and normally aspirated, talk about a ton of the other stuff we miss. Just I hope nobody thinks I was trying to avoid them. I just go off on tangents. Sometimes I have the attention span of a chipmunk. So.
No, we got a great group of listeners, honestly.
Yeah, I was very, very impressed.
Yeah, well, they'll be glad to hear that. So, listen, you want to plug Comp Cams? You want to plug your boss a little bit?
I really, it really is a blessing to get to work here. I appreciate all our customers. We have the best customers in the world. I've gotten to work with some great guys. Working at Comp Cams is great. Even as we've grown from 40 people when I started to over 400 now, I hope everybody knows that we really value and respect each of our customers, and we know for sure that without this, we'd all have to grow up and get real jobs. And
none of us want to do that.
That I do not want to grow up and get a real job, so I value every customer we have. Every year we try to make camshafts better than the year before it, and we appreciate all the guys we get to work with.
Fantastic.
That's great.
All right. Well, thank you guys. I really appreciate the opportunity.
No, we thank you, man, and we'll get you back here at some point.
Anytime, y'all just work with it. Professionally, I have to do what my bosses say, but they've allowed me to do this sort of stuff. So big thanks to Chris Douglas and Kevin Feeney and Scooter, Ron, and Rick Sparks. Our ownership group they let me do this. It's a lot of fun.
Well, please, for Mike, specifically, because I did actually head down there and meet Scooter, and I actually got to meet Gordon in person once a long time ago. And I want to tell him that both, I said hello and thank you so much.
Yep.
So it's just fantastic.
Well, I appreciate it. Those guys, it says a lot. I started here when I was 24, 25 years old, and I've never worked for any other guys. So, they say listen to the words, but believe the actions. I love the guys I work with, and it really is an awesome thing to get to do.
Fantastic.
I get to play with race cars for a living. That's the way to do it.
Yeah.
Yep.
All right.
No doubt.
Hey, thank you, guys. I really appreciate it. Y'all have a great night.
Thank you.
Billy.
Thanks.
All right. Bye, guys.
Well, there you have it. The first one with Billy Godbold.
Explained quite a few little things too.
I'm going to have to listen to the show like 6 times.
Mm-hmm. And I told you guys, be ready. Like, what's funny? This is, I don't want to hate on you, Todd, but I got to hate on you a little bit.
Mm-hmm.
Don't hate on him. You're going to ruin a perfectly good show.
Oh, it's just kind of funny. He's saying things, and Tom and I are both taking notes. We're writing stuff down, like all this stuff that we want to go research.
like find your Herbie.
Yeah, it's. I knew that was going to happen.
Yeah.
So you're writing things down when you can just listen to the show again.
No, because I want to. First off, I don't like listening to our own show.
Man.
Do you listen to
we
our own
suck.
show?
Well, no, but
Yeah, I don't ever listen to them. Well, that was fantastic.
Yeah, it was good.
That was really good. Boy, that sprint car deal,
no, that's funny.
I know.
a dry sump pump being a damper on the camshaft
The
side.
thing is, it should be, but you don't even think. Looking at it, you don't think about it.
There were a couple things there that were very, very eye-opening. I hope our guys appreciate and really let it sink in, because there's some good stuff there.
I knew about the lift changes based on, like valve seat angle.
Mm-hmm.
I mean, probably anybody, what was it? Pontiacs had a 30 from the factory.
Yep.
I knew that from a Pontiac, like that they needed a little less, that they seemed to work fine and didn't respond to a lot more. You know, so yeah, some of that stuff was
they're always low lift, high torque, low RPM.
Yeah, some of that stuff was stuff I had run across, but that's pretty interesting. I mean, there was like Tad said, I probably have to go back and listen to it.
I'm gonna, and I haven't listened to one in a while.
Yeah,
but I'm gonna listen to that one.
Yeah, and you know, again, I know you said it, but thanks again for Ben. You know, trying to help this all along.
Yeah,
I mean, that was fantastic,
and everybody shared it. Thank you for that. I think we had quite a few listeners there.
Well, Mike just called me last week. We were talking about the fuel taking space in the ports and stuff like that, and this falls into
I got to
this too.
say some of the things here, not so much for me, but I think back to all the things my dad said without the data, you know, to back this up. Like, because I had said to him, I said, why if we're doing, you know, because back then it was really, this was before we circle track race. So it was always like, oh, those idiot circle track guys. He's like, he's like, this guy's going to use alcohol. It was a 339 injected thing. He's like, got to get a little bit bigger cam than we normally sell on these guys. And I was like, why? He's like, well, the alcohol takes up airspace. And he's like, so it essentially kind of makes the port act a little smaller. They can tolerate a little more camshaft. And he's like, that's just, but I mean, these are the things that the people that were doing like the dyno work and the research before they had this data available figured out. And like the Cloy's double wide, you know, nylon gear timing chain.
Yeah,
it dampened out vibrations.
I knew about that. Yeah.
And I mean, I remember people saying like they were taking, even then because of 2 barrels, we couldn't use anything like belt drive or any of that shit.
Yep.
People would take 2 barrels apart and look at these guys. They're using a nylon top gear.
Yeah,
What a bunch
idiots.
of cheap bastards. Yep.
The factory GM one was the most popular one, if I remember.
Yeah, there's a factory GM one. It was a performance one. It was wide.
Yep.
And that's where we used to get them from. This was so messed up. We used to buy the gear, the top gear from GM. The bottom gear from GM was powdered metal.
Yep.
So you'd buy a steel bottom gear from Cloy's.
Yep.
And then we got the chain from somewhere else. It was crazy.
Like roll on or something.
Yeah. And then Link Belt changed the design of the chain. They were junk. So then we had to go hunting. I mean, it's just, that's down retard highway.
Yep.
All right. Well, I got to tell you, I'm happy.
Me too.
Oh, yeah.
How about you, Todd? Did you enjoy yourself?
Yes.
You know what's funny?
Hey, at one point, I don't know if you saw the chat room, but I think Aaron asked for somebody dumb next week because his brain hurt.
Yeah, they said we'll get fun.
That's right. You did say fun. Yeah.
But luckily, Tad went out to grab a cup of water right when Billy Godbold talked about diesel stuff.
Damn it.
So now
So I do have to listen
Now
to it
you have
again.
to listen. Yeah.
Yep. Sorry. Well, we'll see you next week.
Yep.
And thank you, everybody. Appreciate it.